Hello everybody and welcome back to Advanced Maths. Today we're looking at further integration in which you're going to learn some more integration rules. And you should already know what integration is. You should know it's the opposite of differentiation. You should be really confident with this and you should know all the rules, the basic rules about integration, where you're handling just powers of x. But today we're going to expand these rules and we're going to learn some more ones. If you're not already confident with differentiation and integration, please watch my earlier videos on differentiation and integration before we continue. But if you are happy with this, let's look at one of our first examples. We're going to integrate ax plus b to the power n. So this is a bracket to the power n. And what we do is we add 1 to the power. We keep the bracket the same, it's still ax plus b. We divide by the new power and the a, and then finally we have a plus c on the end. Okay, so there's 4 things to kind of remember there. It looks complicated, but if you remember those 4 things, you'll be okay. So you keep the bracket the same, add 1 to the power, divide by the new power and the a, and then plus c on the end. So let's see this in action. We've got 3x minus 10 to the power 7. That's the a is 3, the b is minus 10, and the power is 7. So we're going to keep the bracket the same, but we're going to add 1 to the power. So it's 3x minus 10 to the power 8, not to the power 7, to the power 8 now. We've added 1 to the power. And we're going to divide by the new power and the 3. So that's 1 over 3 times 8. And then we put a plus c on the end. And that's it. That's all we have to do. So it's the same bracket to one higher power, divide by the 3, divide by the 8, and put a plus c on the end. That's it. And we can simplify it a little bit. 1 over 3 times 8 is 1 over 24. So we just simplify that 3 times 8, and that's absolutely finished. That is it. That's done. Okay, so that's the rule for when you've got an ax plus b to the power n. That's how you integrate it. Next, integrating e to the power x. E to the power x integrates really simply to be itself, e to the power x plus c. You might remember this rule from differentiation, where e to the x differentiates to be itself. Well, it also integrates to be itself. It's really nice. Just add the plus c on the end. Same with if it's 5 times e to the power x, or any number times e to the power x. This is just 5e to the power x plus c. Very nice. Now we can look at e to the power ax, where there's a number multiplying the x inside the power. Well, this integrates to be 1 over a, e to the power ax plus c. So all we're doing here is dividing by the a. So there's a number in front of the x, we divide by that a. For example, integral of 8e to the minus 2x dx. Well, the power remains the same. It's still e to the minus 2x. It's still the same power, but we divide by the minus 2. So we're 8 divided by minus 2, and then we put a plus c on the end. And 8 divided by minus 2 is minus 4. So the e to the minus 2x will stay the same. We're just dividing the number at the start by the power. Finally, let's look at a slightly more complicated example, e to the power ax plus b. And here we divide by the a again. So it's 1 over a, e to the power ax plus b, and then a plus c on the end. An example of that is this, integral of 10e to the 7x minus 2 dx. Well, it's still e to the 7x minus 2, but the number at the start, the 10, is divided by 7. So the e part stays the same, the number at the start is divided by 7. And then we put a plus c on the end. So we get 10 sevenths e to the power 7x minus 2 plus c. That's the rule for integrating e to the power x. Let's continue. Now we're integrating 1 over x. So this is x to the power minus 1, but because it's specifically x to the power minus 1, we have a different rule for this than the usual power rule. And this integrates to be ln of x plus c. So this is a special case where it's 1 over x is the only kind of power of x that integrates to be something that isn't a power. It differentiates to be, integrates to be ln of x plus c. Similarly, it's 7 over x dx, that is 7 ln x plus c. So the 7 just multiplies the ln of x there. And so this only works for x to the power minus 1 or 1 over x, which are the same thing. Remember, for other powers of x, like 1 over x squared or 5 over x to the power 9, these are different powers. And so you would use the normal power rule, where you add 1 to the power, divide by the new power for those. But for x to the power minus 1, we have a special rule. Now let's look at integrating 1 over ax plus b. And this becomes 1 over a ln of ax plus b. So we just divide by the a here inside the bracket. The bracket stays the same, like this. And let's look at an example of this. Integral of 1 over 2x plus 3. We divide by the 2, and then it's ln of the bracket. And we just put a plus c on the end. Very, very simple, very, very nice. Now let's look at another example, integral of 2 over 6 minus x dx. Well, it's the same as 2 over 6 minus 1x. So you have to imagine there's a minus 1 here. So the number in front of the x here is minus 1. The a is minus 1. We have 2 divided by minus 1. The 2 on the top remains the same. ln of 6 minus 1x plus c. And 2 divided by minus 1 is minus 2, so it's minus 2 ln of 6 minus x plus c. Now let's remember how to differentiate sin, cos, sine and cos. Well, it goes in this circle here. Sine differentiates to cos, differentiates to minus sine, differentiates to minus cos, differentiates to sine, and the circle continues. It's an infinite continuous circle of differentiation. And integration is the opposite. So we go in the opposite direction here. Sine integrates to minus cos, integrates to minus sine, integrates to cos, integrates to sine. And here we got integrating sine of x and cos of x. Let's look at this example. So integrate sine of x, we get minus cos of x plus c. And if we integrate cos of x dx, we get sine of x plus c. And what I like to remember here is sine integrates negative. Sine. So you can remember that the sine function integrates to be negative. Sine, spelling out sine. Okay, sine, sine integrates negative, whereas cos integrates to be positive. Now let's look at sine of ax dx. Here we just divide by the a. Similar to all the other examples I've shown you today, whenever you've got a number multiplying the x inside the bracket, it will normally divide outside, like these. And then we've also got ax plus b's in the bracket, very similar. Again, the number in front of the x just divides outside. You might want to pause the video and copy all these down and see the patterns at play here. Let's look at some examples though. So let's say we've integrating sine of 5x dx. That's equal to minus 1 over 5 cos of 5x plus c. Because you just divided the number inside the number at the front by 5, because 5 multiplies the x inside the bracket. And sine integrates negative, so sine will integrate to be minus cos. This rule here, and let's put some numbers in. 6x minus 1, we divide by 6 and integrate the cos to be positive sine plus c. The bracket remains the same. Now let's look at an example of this in action. So the derivative of the function of a function is f dash of x is 2 over 2x minus 3. The function passes through the coordinates e plus 3 divided by 2, 6. Final expression for f of x. Okay, so we've got the derivative of f here, f dash of x, and we're going to integrate it to find f of x. So if we integrate f dash of x, we get f of x. And we're going to use our rule here for integrating 1 over ax plus b. And we get 1 over a ln of ax plus b plus c. So we take the 2x minus 3 and we're going to divide by 2. And when we do this, we get 1/2 times 2 ln 2x minus 3 plus c. So the original fraction was multiplied by 2. The new fraction is going to be multiplied by 2, but also divided by 1/2. It's going to simplify very nicely. 1/2 times 2 is going to be 1 ln of 2x minus 3 plus c. Now, what's really nice here is we've got the coordinates. We've got e plus 3 over 2, 6. I'm going to substitute those coordinates in to find what the plus c is. So we'll substitute these coordinates in, the x as e plus 3 over 2 and the y as 6 to find the plus c. So f of e plus 2 over 3, e plus 3 over 2 equals 6. And we can put that in to replace the x. And that is equal to 6. The 2 and the 2 cancel. We've got times by 2 divided by 2 there. And that bracket simplifies. E plus 3 minus 3. The plus 3 and minus 3 also simplify. So it simplifies very nicely. This is very deliberate in the question that they set it up this way. And then we've got ln of e. Well, what power of e makes e? Just think about your logarithms here. And that's just 1. So you should know that ln of e is 1. And so you can write this as 1 plus c is 6. So it's simplified really nicely here. We take 1 off both sides. C is equal to 5. And that's the correct answer. So we put that back into the original function. We've got f of x is ln of 2x minus 3 plus 5. We've found what the original function was. We have finished the question. That's it. Okay, so I've got some practice for you to try here. We're going to integrate all of these functions here in your own time. So I'd like to pause the video now and try these yourself. And when you're ready, press play and I'll reveal the answers in 3, 2, 1. How did you do? Let me know in the comments if you got any of them correct. If you didn't get them all correct, maybe rewatch parts of this video again so you really understand the patterns of integration. Thanks for watching this week's video from Addvance Maths. Please like and subscribe to support the channel. It really helps share these resources with more people around. And you can also check out advancemaths.com for more free revision resources to help you master your exams. Thank you for watching and good luck in your exams.